Hello everyone. Today we will be learning about the reactions of metals in water. First we'll be starting off with metals in cold water. So some of the metals that react in cold water are lithium, potassium, sodium and calcium. So you can see that I have written the chemical symbols right next to them so you become familiar with them. When metals react with cold water, they would produce hydrogen and also a metal hydroxide. So let's see the reaction. We have sodium here reacting with water, and when sodium reacts with water, it forms sodium hydroxide and also hydrogen. Now let's write this in a chemical formula way. So here we have sodium reacting with water. Sodium is Na and water is H2O. So when they react, they produce a hydroxide, and this is called sodium hydroxide. Sodium hydroxide is NaOH. Remember I told you OH, the hydroxide ion, has a valency of -1, and sodium from your periodic table you can see has a valency of +1. So when you write it in a chemical formula, it gives you NaOH. And then we have our hydrogen gas being produced as well. Now hydrogen gas is a diatomic particle. That means it's going to have two hydrogens bonded together. We've written all the states down. So sodium is a solid, water liquid, and the sodium hydroxide that is produced is going to be in aqueous form. And also a hydrogen gas is a gas. And you have to balance all your equations. So we have two sodium molecules reacting with two water molecules, and they would produce two sodium hydroxide molecules along with one hydrogen gas molecule. Now we're going to write an ionic equation. Now ionic equations you might be asked to write in your exam. So when you're writing an ionic equation, what you first have to do is see which one of these have ionic bonds. Now if you remember back, ionic bonds are between metals and non-metals, right? So that means here we have a metal, but it doesn't have any ionic bonds because it's not joined to any other element. We have water here. Water is just written as water. It's not an ionic particle. But then we have sodium hydroxide. Now sodium hydroxide has an ionic bond between the sodium and the OH ion. And then we have hydrogen gas, which has only a covalent bond between the two hydrogens. So from all this, only this has an ionic bond. That means when you're writing this, you're going to split it into two ions. This sodium is going to be your cation, and your hydroxide ion is going to be your anion. In other words, it's going to be negatively charged, while our sodium is going to be positively charged. Now when you're writing it, this is how it's going to look like. Our sodium is going to stay the same. Our water is going to stay the same as well. But when you're writing your sodium hydroxide, you'll have two sodium hydroxide ions reacting, also being produced with two hydroxide ions. Now you can see that the two from here has gone into both of them because we have two molecules of sodium hydroxide being produced. Therefore there's going to be two of the sodium ions and two of the hydroxide ions. And then you just write your hydrogen gas just as it is. So this is your ionic equation where you have split up the ionic bond. Now let's see how you would test the hydrogen gas that is produced when a metal reacts with cold water. To test it, we use what we call the pop test. With the pop test, firstly, you would introduce a lighted splint to the vessel that contains your hydrogen gas. So for example, you might collect your hydrogen gas in a test tube, like over there, and then you would introduce a lighted splint to your test tube. When you do introduce it, if there is hydrogen gas present, a small explosion or a pop will indicate the presence of the hydrogen gas. So what you have to look out for is a small explosion or a pop. It's usually a pop sound that goes pop, so you can see that hydrogen gas is being produced. Now to test for hydroxide ions, because the metal when reacting with water would also produce metal hydroxide. So when you're testing for your metal hydroxide, we would use an acid-base indicator. Phenolphthalein or litmus is mainly used. Now phenolphthalein would turn pink, like over there, if there is hydroxide ions present. And also red litmus would turn blue if hydroxide ions are present, because hydroxide ions are a base, so that's why it would indicate a presence of a base. Now let's look at a redox reaction. If you remember back, redox reaction have two half reactions occurring in it. One is a reduction reaction and the other is an oxidation reaction. Now between these two reactions, there is a transfer of electrons. Now if you look at this, we have sodium reacting with water to form sodium ions, hydroxide ions, and hydrogen gas. So in other words, what happens is the sodium displaces the hydrogen in the water. So the sodium ion would get attached to the hydroxide part of the water. So this involves an electron transfer from the sodium atom to the water molecule. So there's an electron transfer between these, making this a redox reaction. Now let's look at the oxidation part of it. The oxidation part is when it's losing an electron. We have sodium losing the electron to form a sodium ion along with an electron here. So as you can see in the animation, we have sodium losing its electron to form a sodium ion. Now in the reduction reaction, what happens is the water molecule would gain 2 electrons to form hydrogen gas and a hydroxide ion. As you can see, we have water joining to form the hydrogen and the 2 hydroxides, as you can see there. So that's how that works. Metals reacting with steam. Now metals also react with steam. For example, zinc reacts with steam to produce zinc oxide and hydrogen. Now let's look at this. We have zinc and steam reacting to form zinc oxide and hydrogen. Now when you're writing the chemical equation for this, you would write zinc in its chemical formula as Zn, and that's found in your periodic table. We have steam, which is practically water in its gaseous state, so it's going to just be H2O. It's going to form zinc oxide. Now zinc has a valency of 2, and also oxygen has a valency of -2, which means the valencies cancel out and you're not going to have any subscripts, and you're going to have ZnO as your zinc oxide. And we have hydrogen gas being produced, which is H2, because it's a diatomic molecule. And again, write all your states down. We know zinc is a metal and it's going to be solid. Our steam is going to be a gas, so the water is in its gaseous form, so you would indicate it as a G. And zinc oxide, it's a metal because it's a metal oxide. And then we have our hydrogen gas, which is also a gas. Some metals don't actually react at all, and they are called inert metals. One is gold, silver, and also we have platinum that doesn't react with anything, so no water. And copper is also one of those that don't react with water or steam. So they're very inert and very unreactive. Now let's just summarize what we just did. So we have rapid reactions, very rapid reactions happening with potassium, sodium, and calcium. Then we have slow reactions happening with magnesium. The metals that react with steam are aluminium, zinc, and iron. And metals that don't react at all are tin, lead, copper, silver, and gold. So as you can see, this is a summary of what we just learned.